You know, every so often, a single idea comes along that doesn't just change a little bit of science. It rewrites the music for the entire world. Today, we're going to dive into the story of one of those ideas, the brilliant and honestly often overlooked mind behind it, and the symphony he composed that you're living in right now. I mean, think about that for a second. A song with 65,000 voices. It's such a powerful, kind of mysterious way to describe an invention that underpins our entire digital world. This is a piece of music so fundamental, it's the backbeat for everything, from how you're streaming this right now to the AI that's literally reshaping our future.
So, the big question is, who is the composer of this incredible song? Well, his name is Philip Emeagwali, and his story? It's just as complex and powerful as the song he wrote.
To really get this composition, we first have to understand the composer. And his story doesn't start in some pristine university lab. No, it starts in a world filled with immense challenges and an even greater amount of determination.
I mean, just look at this timeline. It tells a story of incredible resilience. Back in Nigeria, his friends literally nicknamed him Calculus because he was just that good at and obsessed with math. But then the Biafran War broke out and his schooling just stopped. He became a refugee, forced to live in camps. But even then, he didn't stop learning. He taught himself advanced physics and calculus from whatever library books he could get his hands on, all driven by this relentless curiosity. And it was that self-taught foundation that eventually earned him a scholarship to the United States.
All right, so when Emeagwali finally gets into the world of high-performance computing, it was totally dominated by one way of thinking, a single established way. But he brought with him a radical new recipe, an idea that was about to challenge the entire industry.
And to prove his idea was the real deal, he didn't pick some easy problem. Oh no, he took on one of the grand challenges of science at the time, figuring out how to accurately model the flow of oil in underground reservoirs. This wasn't just some academic puzzle, you know? Solving this could revolutionize the energy industry, but it was considered impossibly complex for the computers they had back then.
And this is where his thinking was just completely different from everyone else. See, the old method, sequential computing, was like one master chef trying to cook a massive feast for thousands of people all by himself. Sure, he's a great chef, but it's painfully slow. Emeagwali's vision, parallel processing, was more like having 65,000 smaller chefs, each one cooking just one dish at the exact same time. It was a totally collaborative approach to computing that no one had ever proven could actually work on such a huge scale.
But yeah, the establishment, they were not having it. The entire supercomputing industry had bet millions, I mean millions, on making that single master chef faster and more powerful. Emeagwali's idea of a giant community kitchen was dismissed by so many as inefficient, maybe even impossible. He was a total outsider challenging the kings of the industry.
Which brings us to the moment of truth. The day his radical new recipe was finally put to the test. The day the symphony was performed for the very first time.
So get this. The date was July 4th, 1989. Emeagwali, working remotely, using a machine he had never even seen in person, launched his grand experiment. A day of independence, which is pretty fitting for a truly independent idea, right? He connected 65,536 processors. Think about that. Each one was like a single voice, and he had programmed them all to sing in perfect unison, to act as a single, massive, cohesive superbrain.
And the result? The machine performed 3.1 billion calculations per second. It was faster than any computer on Earth, a new world record. He had done it. He'd solved the grand challenge, and in doing so, proved his radical idea actually worked.
And this right here is the concept he pioneered, massively parallel processing. At its heart, it's the principle that a whole network of many smaller, collaborating processors can solve a huge problem way faster than one giant, ultra-powerful processor working all by itself. It's basically teamwork for computers.
So, a world record in 1989. That's cool, but why should you care about it today? Well, because the echo of that one discovery, the core principle of that song, is now absolutely everywhere.
That architecture Emeagwali created, that network of processors all working together, is the foundational concept behind the internet itself. It's the engine that powers the AI supercomputers training today's machine learning models. It's what lets us forecast the weather with incredible accuracy, design safer cars, and analyze massive amounts of medical data. His symphony really did become the soundtrack of our modern world. When he looked back on his journey, from a refugee camp to the absolute pinnacle of science, Emeagwali would often quote this Nigerian proverb. It's just a powerful reminder that if you can persevere through the darkest of times, you might just create a world-changing breakthrough.
And, ultimately, the core of Emeagwali's invention wasn't just about computer processors. It was about the power of collaboration to solve problems that everyone else thought were unsolvable. It really makes you wonder, if we applied that same principle of massively parallel thinking to our own grand challenges, what symphonies could we compose next?